Hi guys, so in this video we will talk about chain rule. Okay, so what actually chain rule is? So for example, you already learned that the derivative of x squared is 2x, right? So this is the power rule. But let's say I have something more complicating. Instead of just x squared, I have x squared plus 3 to the power 2. What did that equal? Okay, of course, in this problem, it's still not too complicated because I can still apply the formula a plus b squared equal a squared plus 2ab plus b squared, right? Then my a is x squared. So this will be I will be able to expand this become x to the power 4 plus 6x squared plus 9. Right? And then we take the derivative from that, which is 4x to the power 3 plus 12x, and then plus 0, because the derivative of constant is 0. Okay, so which is okay. That is a derivative. But if we have something like d over dx, and then we have x to the power 2 plus 3 but raised to the power 5, then can we do the same thing, expand this? This is going to be pretty long and hard, right? So is there a better way that we can take the derivative without doing the expansion? So this is where we actually need to apply chain rule. Okay, so how do we apply chain rule? Let's take a look at the simple example. Is x squared plus 3 to the power 2. Okay, so the chain rule is say this is look like the composition function where my outside function is a power 2 and my inside function is x squared plus 3. Okay, composite function. So the f of x is the outside function and then my g of x is x squared plus 3 x squared plus 3, because if you think of f of x is x squared and g of x is x squared plus 3. Then when I do f of g of x, then I will have x squared plus 3 and the whole thing raised to the power 2. Okay, so this is the composite function. So in order to do the composites, the derivative of the composites, we need to apply chain rule. So what we're gonna do is we're gonna let our the function inside, we call this the inside function, x squared plus 3 to be u. Okay, if that is u, isn't that based on the derivative, we're gonna have to take the f prime of u times u prime. So this function will become d over dx u squared. And in order to take the derivative of u squared, we're gonna have 2u times u prime. Okay, and how do I find u prime? U prime is the g of u is the g of x. So g of x is u is g of x, which is x squared plus 3. Now, what is u prime? U prime is 2x. So all we have to do is replace everything that we see u by x squared plus 3 and u prime by 2x. And we end up having the answer will be 4x times x squared plus 3. If we distribute this into the parentheses, I will have 4x cubed plus 12x. And that exactly the same answer where we expand it and take the derivative. Okay, the process doing this is called chain rule. So what chain rule used for? Chain rule is used for a function that is a composite. So you have one function inside another function. Okay, so in order to apply chain rule, we're gonna take let u be the function inside, take the derivative of outside function and times the derivative of inside. Okay, so let's apply another example for that. For example 1, so I have y equal 3x to the power 5 minus 2x squared plus 5x to the power 5. And I want to take the derivative of this. I do y prime. And what is my inside function? Inside will be the 3x to the power 5 minus 2x squared plus 5x. So I'm gonna label that as u. So my u is 3x fifth minus 2x squared plus 5x. And I'm gonna replace that by u, then I'm gonna u to the power fifth. And I need to take the derivative of that. So my y is u to the power fifth. My y prime will be 5 times u to the power 4, and then times u prime. And what is u prime? U prime will be 15x to the power 4 because we bring down the 5. So 15x to the power 4 minus 4x plus 5. So we're going to replace everything back to the x variable. So our y prime will be 5 times 3x fifth minus 2x squared plus 5x to the power 4. And then times u prime will be 15x to the power 4 minus 4x plus 5. Okay, and that is our answer when we apply chain rule.